So you are flying from JBLM to a location 273 kilometers south and 221 kilometers east. Mount Rainier is located 56 kilometers east and 40 kilometers south of JBLM. Assuming constant speed of 800 kilometers per hour, how long after you depart JBLM will you be located or will you be closest to the Mount Rainier? So let me go to the next page. First, let's do a picture. So let's locate or put JBLM in 0, 0, because we are starting from JBLM. Now, if you are going to 221 kilometers east and 273 kilometers south, then 273 must be negative because now we are going east and south. So here's the location right here. The problem is saying this location is unknown. They just don't have we don't have a name for it. So we'll just leave it as a point. Mount Rainier here, we are told that the Mount Rainier is 40 kilometers south, 56 kilometers east. So here's the location of Mount Rainier. So the airplane, you keep going this way. And the question is, how long does it take you to have the smallest distance to the center of Mount Rainier? That's essentially what it means. So pretend that this point right here is this point is the center of Mount Rainier. And so as you get away from that center, just let's put a few circles. Notice that at some point you're gonna touch that circle, that the point of tangents is somewhere in here. And we do have, from our previous knowledge, we should know that this radius from the center, this radius tangent to the path that the airplane is taking will have a 90-degree angle. That theorem was disclosed to us sometimes at 9th grade. I believe I don't teach high school, but 9th or 10th grade. So we do have a 90 degrees in here. We can use that. Okay. So let me go to the next page. We know that the path between JBLM and the final location is straight line of y equals mx plus b. So first, I'm going to go ahead and use the coordinate points and find the slope. Well, the slope is the change of y over change of x, in this case, negative 273 over 221. And remember that we said in our picture, we said that this is our 0, 0. So if you think of this as, let me just add, let me get green. Let's say that if this was my y axis and this is the x axis. So if this is the x-axis and this is the y-axis, notice that the point of intersection or the value of b is 0. You could also calculate it. So with the b or y-intercept being 0, the equation for the line of the path from the JBLM to the final destination is y equals negative 273 over 221x. You could have a plus 0 if you wanted to. It doesn't matter, but you don't have to. So now, let me go to the next page. How can I use that? I can use it. I know that the slope for that line, m, is negative 273 over 221. So a line perpendicular to it should have a slope of opposite reciprocal. So m perpendicular, the slope of a line perpendicular to that line has a slope of positive 221 over 273. Okay. So now that I have, now I'm going to go ahead and use this information and use the coordinate points that I have and find the equation of the line for that is perpendicular to the line, to the path from JBLM to the final destination. Okay. Using the coordinate point, I get y minus negative 40 equal 221 over 273, x minus x1 or 56. Okay. Distributing, first of all, minus 40 is positive 40, and distributing 221 over 273, now I have y plus 40 equals all that. And subtracting 40 from both sides of this equation, minus 40 here and minus 40 here. So I have y equals 221 over 273x plus 85 and a third. And so now this is the equation of the perpendicular line, the line or that is going from the center of Mount Rainier, okay, and it is crossing the path of the airplane. So now I need to find the point of intersection. I need to find, and go back to the drawing. I need to find this point of intersection right here. Okay, so remember at that point of intersection, both equations have the same value. So I'm going to set them equal to each other, like we did in the past. Okay, setting both equations equal to each other, subtract 221, negative 221, or yeah, subtract 221 over 273x from both sides. And I used my calculator. This is what I get. This value, negative 2.04 on and on x equals negative 85 and 1/3. Divide both sides by negative 2 by the coefficient of x, and you get x equals 41.73150684. So now I'm going to substitute this x value into any of those equations and find the y value. Okay, so plugging 41.73150684 in any of the previous equations gave me the y value of negative 51.55068492. So now I can find the distance, okay? I can find the distance between, let me go back to the drawing. See, now I can find this distance right here using distance formula. And since the location of JBLM is 0, 0, it makes it very easy. So using distance formula, I get a distance of 66.3248956.2. And finally, now that I know the distance, we know we are given that the speed of the airplane is 800 kilometers per hour. I need to convert that to minutes. So I'm going to go ahead and divide that by 60. I get 13 and 1/3. And I know distance equals speed times time. Therefore, time equals distance divided by speed. So let's go ahead and do the division. Time equals distance divided by speed, and that is going to give me 4.974367164 minutes. Okay, I think the WAMAP usually asks for like 4 decimals or at least 1 decimal. I'm not so sure in this case. And okay, well, that's it for this problem. I'll talk to you later.